Okay, now for our next parts. So we have a randomized experiment was conducted to determine whether taking a particular drug regularly would decrease the chance of getting a certain disease. For each of the experiments, the drug is the difference between the proportion of people taking the drug who got the disease and the proportion of people taking a placebo who got the disease. If the drug had no effect whatsoever, that means we're going to fail to reject the null hypothesis. Which of the following experimental results would be anticipated? A p-value larger than 0.05. Yes. If we're going to fail to reject it, drug didn't have any effect. There would be an equal number of positive and negative values of the drug effect. That means on one group, we had more people that got the drug, the disease, taking the placebo, and another group, we had more people who got the disease taking the drug. So we'd have positive and negative values there. And if we did a 95% confidence interval, 0 would be in the interval, about 95% of those intervals. So this answer is E. It's all three of those. All of those would occur. Okay, question 32. As part of a project, a random sample of 12 students, regression analysis from those students. She wants to compute a 95% confidence interval with a slope in the population field of the slope. Assuming the conditions for inference are satisfied, which of the following gives the margin of error for the confidence interval? The margin of error for a confidence interval. Okay, so our star value here is 2.228 for all of them. And so we multiply, I refer you back to the other problem, the margin of error is the critical value times the standard error. Well, the standard error for study hours, that's what we're talking about here, for study hours is 0.745. And so that is that answer right there. Sorry, interrupted by a phone call. Isn't that crazy? Okay. So it gives us the standard error, and that is obviously the z-score. Okay, this then comes the fun question. This is the one that keeps the people from making 4s and 5s. Mathematics competition goes as follows. For each correct response, they get 7 points. For each left unanswered, they get 2 points. For each incorrect response, they get 0. If there are 5 choices for each question, what is the minimum number of choices the student must eliminate before it's advantageous to guess? Okay, so advantageous to guess means they get a score above a 2. Because if you leave it blank, you get 2 points. You get 2 points for admitting your ignorance, I guess. So, but if you do guess and you get it wrong, then you get 0 points. So all of you thinking, well, if I can eliminate 4 of them, then I get, it's the best thing. That's not what it's asking. Which of these gives me an expected value of a number greater than 2? Well, I'm going to say eliminating 0 is not the choice. So we're going to start with 1 and work our way that way. So to get 1 right, to eliminate 1, oh, I don't have an eraser. Okay, so that means that the probability of getting it right is going to be, you eliminate 1, that gives you 4 choices. So that's probability is 3/4. Okay, and then that's, if you do that, then you get 7 points. So that's, oh, sorry, you have 3/4 chance of getting it wrong, 1/4 chance of getting it right. There we go, and 3/4 of getting it wrong, right, and you get 0 points. So the expected value of this is 7 times 1/4. 1/4 of 7, which is 7/4, which is approximately, well, no, it's exactly, sorry, 1 3/4 or 1.75. That's not greater than 2. It's close, so I bet our next one works. If I eliminate 2 questions, then the probability of getting it right is 1/3. Probability of getting it wrong is 2/3. So this is 7 points. That's 0 points. So 7 times 1/3 is 7/3, which is approximately 2.33. So then the answer, the best thing to do is if you can eliminate 2, you get more points. All right. Number 34, probability a microwave stop working in less than 2 years is 0.05. Probability the new microwave is damaged during delivery and stops working in less than 2 years is 0.04. The probability the new microwave is damaged during delivery is 0.1, 10% of the time. Okay. Given that the new microwave is damaged during delivery, okay, so we're given it's damaged, which is 0.1. What's the probability it stops working in less than 2 years? Okay, less than 2 years is 0.05. So stops working. Oh my. Okay, so what we want to look at to determine our answer here is to find the probability of these two, of this and this, which the probability and delivery and stops working is 0.04, divided by 0.1, the probability that it's damaged, given that it's damaged. And that number is 0.4, so that's 40% of the time. Okay, number 35. Y'all didn't see any bit of that, did you? I just had every bit of that pushed up out of the way. Okay, one more time. Probability it stops, given that it's damaged, is the probability delivery and stops working is 0.04, divided by the probability it was given that it was damaged, which is 0.1, that's 0.4. Okay, 35. They're using rocket fuel here, this chemical. People live by think it may be in their drinking water. Is 24.5 parts per billion or less is safe. Random sample of 28 of those gives me a 25.3. Which of these would be the appropriate alternative hypothesis that addresses this concern? Okay, anything greater than 24.5 is bad. So we want mu, where our alternative should be that mu is greater than 24.5, because our null would be that it equals 24.5. That's our parameter. And then this is our X bar that we're working with. So mu is always given with our hypotheses. So greater than 24.5 is D. Okay, so this one, linear regression found below, predicting the concentration of zinc. So it's zinc hat equals 16.3, my initial value, plus 19.0 lead. Because lead determines how much zinc is in this. What does this number mean? What's the correct? I put this over 1. Rise over run. Independent is my denominator. So it's 19 parts zinc per 1 part lead. 19 parts zinc for every 1 increase in lead. That answer is B. And my grandson over there talking in the distance. 4 more, sorry. Okay. 5,300 homes sold in the year 2000. Distribution is strongly right skewed. Mean of this, standard deviation of that. If all possible random samples of size 100 are drawn and the mean is computed from all the samples, what's the sampling distribution of the mean? Okay, mean distributions are always, mean distribution is always going to be approximately normal. So it's one of these 3. Okay, my mean's going to stay the same, so it's one of these 3. Now, standard deviation for the sampling, you take the sigma, 37.881, or comma, divided by the square root of n. N is 100. So that's divided by 10, move my decimal over 1, that's $3,788. Okay, that's always that way. The standard deviation is determined by this the distribution standard deviation divided by the square root of n, the size of our samples. Mean stays the same. Okay, 38. Physician believes exercise habits on the East Coast are different from the left coast. To study this, she gathers information on the hours of exercise per week from a random sample of East Coast and West Coast adults. Which of the following might be an appropriate null hypothesis? Null hypothesis. The numbers are the same. They are equal. Is different? No. Is the same as? Okay, here's a choice. Is greater than? No. Is less than? No. Equal number. Okay, here's a choice. The probability 0.05 from the East Coast adult and a West Coast adult. Oh, there's a 50% probability. No, that's not my answer. So here's the same. Again, this was wrong. This is my answer, B. The average number is the same as the average number. That's my null hypothesis. Null is always equal to. Okay, two more. Okay, so we roll a pair of dice. Okay, we have two dice. We have a red one that's numbered 1, 2, 3, 4, 5, and 6. We have a green one that's numbered 1, 2, 3, 4, 5, and 6. We roll this one and this one at the same time. We subtract this minus this. 1 minus 1 is 0. 1 minus 2 is a negative 1. 1 minus 3 is a negative 2. Okay, 2 minus 1 is 1. 2 minus 2 is 0. 6 minus 5 is 1. 4 minus 5 is a negative 1. So I'm going to get positive and negative answers. So these do not have positive and negative numbers on them. Whoops. E's the other one. So E doesn't matter. Okay. So we're looking at C or D. Well, which of these are most likely to occur the most often? Well, 5 minus 1, 6 minus 1 gives me 5. 1 minus 6 gives me a negative 5. That only occurs one way, but each of these straight across all give me 0. So 0 is more likely to occur than any other difference. Okay, 0 is more likely to occur than any other number. This is the best distribution right here. So the answer is C. And last but not least, probability of winning a game is 50%. If at least 70 of the games are won, the player wins a prize. If at least 70 of those. So if the possible choices of n are 10, 20, or 100, which value of n should the player choose in order to maximize the probability of winning a prize? Okay, this is 3 out of 10 winning. Does everybody understand that? This is 6 out of 20. Both of them the same percent, but there's more chances of losing here. There's only 7 chances of losing here. There's 14 chances of losing there. There's 69% chance of losing there. So the best one to choose is the lower value is A. So the answer to number 40 is A. Hope they